Okay, so we will talk about several food products, which is fermented products. So we'll talk about from the biochemistry standpoint, what are they, how they do. So the first thing what we want to talk is about vinegar. Okay, we sometimes using vinegar to cooking or using vinegar to prepare foods. So what is that? So first of all, said very easy. This is a secondary fermentation of wine. You can understand about that, but I will put a quotation mark. So what are going to be the example? If you have a red wine, you open the cap, you let the oxygen come in for about a month, 2 months, then you're going to taste it. You will find it's acid. It's like a vinegar. But of course, it may not be edible, may not be drinkable. But I want to tell you one thing, that's what the original vinegar comes from. So, what are the vinegars looks like? The vinegar, we need a substrate. The substrate obviously is alcohol, is ethanol. Okay? Now sometimes this ethanol comes from wheat products, but most of the time it's come from wine. This is the first thing. The second thing is that we need some of the so-called the bacteria. We definitely need the bacteria. So what are the bacteria? Gluconobacteria and acidobacteria. I would say acido. aceton. Bacteria. Major of these two products. Okay, now what we need? Oxygen. This is the key. We definitely need oxygen. What are going to be the products we generate? Makes it, the vinegar looks like vinegar and very acid, is acetic acids. Okay? What are the concentration of the acetic acids? Typically 4 to 8%. Most of the commercial products is 5%. Okay, so this is the overview we talk about the vinegar. Okay, now then we want to talk about how the vinegar is going to come out. What are they? So first of all, there is some of the chemistry reaction. So chemical reaction we want to mention. So we can do a little bit of review what we already talked. Where are going to be the wine originally come from? It's all come from starch. So what is starch? C6H12O5 and okay, that's a starch. Sorry, H10ON. Now starch, we are using an enzyme, basically amylase, will become C6H12O6. We will say it's just a simple sugar, which is a monosaccharides. Okay, once we have this sugar, a single sugar, a simple sugar, then we will find a yeast. Let's say Saccharomyces cerevisiae, then generate what? Alcohol. Okay. OH. This will generate alcohol. Now Now, the making the vinegar is all started from the ethanol, the alcohol. Now, of course, there is a water comes out. Okay, let me double check. Yes, of course, there is a carbon dioxide that comes out. Now, making vinegar all gonna be come from here. So, what are they? How are they gonna happen? C2H5OH, yes, ethanol. Okay, first of all, this ethanol will become CH3CHO, acetaldehyde. This needs an enzyme. What is the name of the enzyme? Is alcohol dehydrogenase. Whenever you see a dehydrogenase, which means they're going to take out of the H2. Okay, how do they take out of H2? Where they go? NAD plus will reduce to NADH2. Nickel-titanium adenine dinucleotides will reduce to NADH2. Now, of course, this process needs oxygen there. So, this is also involved electron transport chain and will generate ATP, is 3 ATPs will generate. Okay, then you have acetaldehyde. We're going to have to go. We're going to go through a transition step. This transition step will become CH3CHOH2. This is called acetaldehyde hydrate. So what's the enzyme of this one? Hydrase or hydratase. Okay, this is acetaldehyde. Once this guy comes here, gonna further react it, will become CH3COOH. This is acetic acid. Now, what's going to be this enzyme? Acetaldehyde dehydrogenase. Okay, same thing. Take out of oxygen. Where this hydrogen? Where this hydrogen gonna go? NAD will be reduced to NADH2. Now, of course, this needs oxygen with electron transport chain. So, how many ATP gonna generate? Again, 3 ATPs. So, you add up them together. How many ATP do you generate when they making a vinegar? A secondary fermentation. Total is 6 ATPs. And this is larger than a homo fermentation, let's say, from pyruvic acids, pyruvate, go to lactic acid. How many ATP going to generate? This is only 2 ATPs, and this is coming from glycolysis. Is that right? That's what we talk about in the biochemistry class. Okay, so this is a reaction, the overall reaction. Now, we want to talk a little bit more about this acetic acid, what it is. So we can draw here about acetic acid. So acetic acids, we also call it ethanoic acid. So what means ethyl means? Ethanoic acid, sorry. ETHANOIC. What is ethyl means? 2 carbon. Okay. What is OIC means? We mentioned about that before. This is carboxy acid. So basically C like this. COH. Okay, so what does acetic acid originally looks like? Acetic acid originally looks like is CH3, then CH3. Originally looks like this. And then you have a carboxy acid going to attack in here. Then later on it becomes like this. Okay, so acetic acid we can also write is C2H4 and O2. However, we don't know the structure, therefore we wrote it as CH3COOH. That's what right now we always see the chemical looks like writing in different textbooks. Okay, so that is acetic acids. So we talk about these chemical reaction, the story behind acetic acid, what it is. So we want to mention how we're going to manufacture the acetic acids from the vinegar. How we manufacturing vinegar. Okay, so we're going to talk about this manufacturing of vinegar. Okay, basically there is 3 methods to do. Number 1 is called orange methods. This is like New Orleans, but we don't say New Orleans, we just say it's orange methods. It's a very old traditional method for a small local processor. Okay, what it gonna be looks like? It's gonna be looks like a channel. Not really a channel, it's maybe a tub. Looks like this. Now at the bottom, we're gonna put some tray there. Okay, so there is a tray. And this tray, usually we also add a valve. This will be the products. So we'll be receiving products, which is vinegar. Now, of course, there is some of the waste going to be right here. Okay, so we draw like this. There's some of the waste. Okay, now how do you do? This whole channel, it is about total volume is about 500 to 600 liter. But we don't fill all the way to the top. We will fill approximately is 60%, 50 to 60%. So approximately 200 to 300 liter fill at the bottom. Okay. Now you're gonna dig a hole on the top, put a funnel there. Some people put like a sprayer. Okay. So what are we gonna add? You're gonna add the wine, and you're gonna add the bacteria. Now the bacteria obviously is acetobacteria, and also we mentioned the gluconobacteria. We're gonna add it. Okay, so they're gonna come in. And then coming, the bacteria will be floated like this with the wine. So So the bacteria is there. And with wine. Now how many is they added? Usually this wine, they added until 200 to 300, but the wine has to refresh 10 to 15 liter weekly. Because the fermentation time is about a week. About a week. Okay, so they're going to have a reaction. Now another thing we're missing, we need oxygen. Is that right? So where going to be the oxygen comes from? The oxygen going to come in from, we will make some of these holes. So on the top we make some of the hole, like this. These holes, we're going to make sure it is a meshed filter. Like that. Okay, what is important for these things? Number one, obviously, these meshed filtered hole, there is one reason is oxygen gonna come in. Because they need oxygen going there. Now why we need to use a filter? We need to prevent dust, pets, and rats. Why? Because this fermentation time is about a week for one batch, and it will be continued to do. And you don't tell me after 1 month you can generate a vinegar and there's a rat there. That's really horrible. Nobody gonna drink it. So the animals, the pets, the rats, and also the dust has to be prevented. That's why they use a filtered meshed hole. Now, how many volume of the vinegar will generate after about a week? It is about 60 to 70 liter vinegar. Now, it's still a lot for a small processor, but for large industry, it's a small piece. And then you have this waste, is that right? The waste could be recycled, which means you're going to go back to do it. And also, we mentioned you're going to have to refresh 10 to 15 liter wine every week. And the whole time took about 7 days. So, this is going to be a slow fermentation time and also a smaller volume generated. Okay, so overall this method is slow time of fermentation and small volume. So this is a very old method. It's called orange method. Right here. Now the second method, make sure the camera is covered. The second method is called trickling method. Trickling method. Oh, it's a trickling process. So what is that? The same thing is gonna be in a large chamber like this. And so what we're gonna do? We're gonna do a large chamber. So large chamber at the bottom. We also have a tray. Okay. Same thing here. It's for a valve for the vinegar products. Now, very important, we need the oxygen coming. So the oxygen is coming from here. We have another hole. And we need to control, the temperature here is 35 degrees Celsius. Above is about 29 degrees Celsius. So, you know, the hot air has a low density So this is gonna be go up like the, like this. Okay, this is gonna go up. Now, the same thing. In here, we're gonna make some of the sprayer like this. Okay, then we add it right here. So we say it's a sprayer. This sprayer, we're gonna be sprayed with wine and with bacteria. So the wine will be dripping like this. Like take a shower. Now, what's the major difference between these two methods? This method just let them happen for the reaction. In the trickling methods, we will add a lot of the piece like this. What are these? Beechwood shavings. Why we want beechwood shavings? We want all these bacteria with wine, especially the bacteria, to attach the surface, and then expand the area to speed up the fermentation. So this is like extended bacteria contact the surface, and will generate possibly is a biofuel. And once the biofuel generates, it's enlarged the area, then the fermentation will speed up. So the whole fermentation is taking somewhere around 72 hours, that is 3 days. Much shorter than a week. Now there is a problem. You have so many beechwood shavings. These has to be recycled used, but you cannot use all the time. So, how are you gonna treat shaving waste? That will be a problem. Could be a problem. Now, in the history, when people manufacture this, generate this method, instead of using beechwood shavings, they are thinking about we could use some of the corn. Is that right? We can use some of the corn. We think about the corn there. There's a lot of niche. And you see here there's a niche. So they hope the bacteria could hide in there, also expanding the area. However, this method is failed. They did not generate the same impact results. So that's why they don't use this anymore. But in the short period of time, people did think about use corn with a niche to do that. But later on, people find the beechwood shaving is a good method to do because it extended the area, generate the biofuel, speed up the fermentation. So it's about like 3 days you can finish it. But this is not going to be enough. That's volume pretty much like similar, 500, 600, 200 liters at most. Now, of course, there is the waste going to generate. Okay, there's the waste right here. And these waste, you can do recycle, go back to recycle, but it's not going to be too much. So, a large industry, what they do is a submerged biogenerator. That's a new method. Okay. Not really new, but it's a large industry they do. It's called the submerged biogenerator. So how they do that one? It is also a chamber, a very large chamber. This large chamber, they're going to dig a hole on the top. The same thing here, comes out with wine and the bacteria. This is always you have to have. Now the difference is that they're going to generate the oxygen, is they are going to using a bladder and a fan. So right here, instead of you dig a hole, you use a shavings, you use a meshed filter hole, filter meshed stuff. You are using is a fan, mechanical fan, or a bladder. Okay, when you have this bladder, of course you're going to have a control panel right here. So that's a control panel, the speed. So when you spill it, and then the oxygen will come out. And then there is another thing here, is the temperature. This is another temperature control panel. This temperature control panel usually will be up to the temperature to 40 to 42 degrees Celsius. With this a little bit higher temperature, the overall methods, the overall fermentation time will be short. Because speed up the fermentation, so the fermentation time will be only 24 hours. That's a good thing. That's why it's going to be generated a huge amount compared to the other methods. This could be up to 2,000 to 3,000 liter, or much more than that within a day. So mass production could come out. Okay, that's why the submerged biogenerator is being using a lot. But the thing is that there is no recycled one. So what you have to do is that one batch by one batch. But the one batch you can have a huge amount. It's 5 or 10 times compared to the other methods. Okay, so this part of what we finished is we talk about is our vinegar processing from the biochemical reaction. So 3 methods and how that goes. Okay, we finished this part. Then we want to talk about something else, which means some of the other fermented products, which is a vegetable fermented products. So first thing what we want to mention is sour, K-A-U-E, sauerkraut. A-U-R-E-K-R-U-E, sauerkraut. Okay, what is sauerkraut? When Derek Warren is here, we did the test. We making the sauerkraut by ourselves. And I asked him, I said, what it looks like. He told me it is salty lettuce. Not really salty lettuce, it's cabbage, salty cabbage sometimes, cabbage lettuce. That's true, because we want to talk about it. Talk about this salt, we're going to talk about the lettuce, especially the salt. There's a lot of the chemistry behind that. Okay, so first of all, we want to talk a little bit about the history behind this guy. Sauerkraut, this is the one is more than 2,000 years. This is originally coming from is the Dutch, Netherlands. They are doing the business to North America back in the old time. Canada and Mexico, United States. And we know about that today. If you have an airline, I mean, before pandemic, you're from Pittsburgh airport. You go Madrid, Spain, it's about 6-7 hours. Go Paris, about 7-8 hours. Back in the old time, they are doing the ocean using boat or shipping there, it took 1 to 3 months. Okay, when they are all in the ocean, what do you have to do? Because of course they do the trade. You need to keep the energy, is that right? Keep the energy, keep some of the, we call it a mineral, all the minor ingredients is supplied sufficiently for you to survive. What is missing when people usually have that long time ocean trip is vitamin C. And the vitamin C is important because if you don't have enough vitamin C, the vitamin C deficiency will have anemia. So, then they think about we can do something for the sauerkraut. Okay, what's that? Why? Because we later on do the measurements, we know the vitamin C, it is about 38 to 50 milligram per liter, okay, in it's a per gram in the sauerkraut. That is almost, if you do a titration, if you're using a chemical titration methods, it is about 0.28 to 0.42% of acetic acids. So, they think about this sauerkraut is a good method to using for the trading, the ocean trading, go to the other countries. That's where they originally come from. Okay, now we want to mention how we make it. We need a jar, of course. And in the jar, we need letters. So we usually buy some of the letters there. Okay, the letters. Cabbage letters, we have to shred it. So that's called shredded cabbage letters. Now, of course, a damaged leaf, you have to take it out. So you put it in. Then we have to cover it. Why we have to cover it? Because we need to avoid the oxygen there. Because we will have to go through fermentation process. We don't want oxygen, so we cover it. Now, what we are covering there, what we are immersed is 2.25 to 2.5% just a salt solution. It is very simple. How long are you going to ferment it? At 20 to 24 degrees Celsius, fermented 2 to 6 weeks. Some people say 3 to 7 weeks. Then you generate a sauerkraut, and the final pH 3.4 to 3.8, and acidity it is about 1.6 to 1.8%. Okay, now we want to mention why this salt is so important. Why this salt solution is so important. There are several reasons for this salt. Number one, this salt will extract sugar. Basically, it's going to be the juice, lettuce juice from surface. Okay, from lettuce surface, from lettuce for fermentation. This is the first step, it is important. We need a sugar for fermentation. Second, we know that most of the bacteria is not survive in a salt environment because we call it a non-halophile. Now, some of the bacteria halophiles, like Staphylococcus aureus, we know about that. So, non-halophile will be died, will not survive. That means you're going to kill background bacteria. And basically these are gram-negative bacteria. That's the second reason we need a salt. The third reason we need a salt. This salt will be promote three major bacteria important for the fermentation. Number one, leuconostoc. This is belonging to lactobacillus lactic acid bacteria family, which is leuconostoc. Second one, lactobacillus. It's a large chain lactic acid bacteria. The last one is Pediococcus. These three bacteria is lactic acid bacteria belonging to lactic acid bacteria family. They need to grow, and later on they even become acid resistant. So actually, you're going to have an acid resistant bacteria going to come out. Now there is a last reason why we need this range 2 to 2.5% of the salt. Because for the firmness. The salt concentration is highly related to the firmness of the letters. So what it looks like? All right here. This is the x-axis is salt concentration. Y-axis is firmness. What's going to be the curve looks like? The curve is not single straight. It looks like this. So they do the research, they find that if the salt concentration is about 0.7%, this is very soft. Also, if you put a lot of salt there, okay, let's say you put 3.4% of salt. This is also become very soft. Why? Because the sugar is gone, the tissue has been almost damaged, osmotic balanced. It's become very soft. Now, at which level it will be very firm? Right in the middle, 2.5%. This is extremely firm. That's what we needed. Okay, so what is it going to be looks like? 0.7 to 1.7%. This is very soft. 1.8 to 2.1%. This is kind of like a median to firm. Then 2.2 to 2.5%, this will be very firm or extremely firm. And then what is going to happen is 2.6 go back to 2.8 or 2.9. This is started back to become medium firm. And once the concentration is almost to more than 3.4%, this will become medium firm. The tissue become medium firm to soft. That's the reason we do like this range. We typically don't want to be soft. Okay? So, sauerkraut, that's what we want to talk. Okay, this next one. This one everybody knows. We do that lots of time. It's called a pickle. So pickle and sauerkraut is very similar, but there is some difference. So we want to talk about that in a little bit more detail. Okay, so what's that? These pickles. Okay, what is a pickle looks like? It's the same thing. I had a job. Okay. What are we gonna add? Cucumber, yes. Of course it's sliced. Okay, slice the cucumber. So slice the cucumber will be there. 1, 2, I did that before in my class. 1, 2, 3, 4, 5. We just, of course we're gonna slice it. Okay. So we're gonna cover with sauce solution. Okay, so number 1, sliced cucumber. Number 2, add the sauce solution. The concentration have to be a little bit higher. 5 to 20%. And we would love to the salt concentration has to be more than or close to 12% all the time. So what's the industry they do? They will refresh every 7 days. Okay, what are they gonna add? Is 1 pound of salt with 1 pound of salt with 2. They do the refreshments is 1 pound of salt into 50 gallon. Is 15 gallon. You can do a calculation for that. Okay. 450 grams. 15 gallon. So 1 gallon is 3,670 ml. So this is ml. You delete this, gonna become 30. So you delete 1. This is approximately 0.09. So it's about 9%. I will say more accuracy will say 8 to 9%. So they refresh it every week to make sure the salt concentration is maintaining around 12%. Now, what's the function of the salt? Very similar. Okay. Now, of course, I forgot to mention this is 30 degrees Celsius, fermented. 1 to 3 weeks. Sometimes longer than that. Sometimes we do 2 to 6 weeks. It depends. Lots of the time, using 2 to 6 weeks. What's the salt going to be used for? Same thing. Extract sugar for fermentation. Number 2, kill gram-negative bacteria. This is number 2. Number 3. Number 4. What they're gonna do is to promote growth of lactic acid bacteria, Leucanus, Lactobacillus, and the Pediococcus. Pediococcus, generally Pediococcus, also curing bacteria. there is a last thing we also want to mention. We don't really care about the firmness here, but we care about the color. What is going to be the color looks like? After you fermented it, the pickles will look like yellow to brown color. Why it will be? Okay, we want to mention. This is number one phenomenon, what it looks like. Number two, if you look at this solution there, originally it's transparent. At the final of the fermentation, it will from transparent to little bit white, translucent. Number three, what's going to happen? Lots of the cucumbers, the pickles will be precipitated. So, they will increase gravity. Now these we don't talk about too much, but we care about the yellow brownish color. Why it will be? This is go back. We want to talk about a little bit about color chemistry. Okay, originally cucumber. I don't have green color here. It's green. What's the color for that? Why it will be green? Chlorophyll. Chlorophyll, is that right? The chlorophyll A and B, different wavelengths. What it looks like? What's the structure? It's a purple ring. At the middle is magnesium with nitrogen surrounded on the four corners. Okay, once you have acids, what's going to be? What's going to happen? Now you know that after fermentation will generate acid. Is that right? The lactic acid will generate. Once the acid comes, what's going to happen? This magnesium will be gone.